So hi, my name is Andrew Ho. I'm a program manager for the Azure Cosmos DB team. I joined about maybe a little longer than 3 years ago. So how many people, just to get started, how many people know about Azure Cosmos DB? Show of hands. Awesome, awesome. Perfect. So this is an overview session. So if you want to get really deep into it, I do have other sessions afterwards that I'll point to, which get a little bit deeper into Azure Cosmos DB. Perfect. For those of you, how many people know NoSQL? I'm guessing the hands should be a little bit more. Okay, perfect. So we'll get started. So this talk is Azure Cosmos DB, the globally distributed multi-model database. For this talk, it will be an overview about the value propositions of Azure Cosmos DB, how it works, some of the details around it, and just why it's really special and why it's kind of garnered the attention of a lot of news outlets. For those of you who are familiar, Azure Cosmos DB got quite a lot of attention at the last build when we announced it. A lot of people were talking about how this database was bringing something really special to the industry. I do want to cover exactly why it's garnered this attention, as well as why people are attracted to it. So some of the value props that make this really special is Azure Cosmos DB has global distribution. It has an elasticity of compute and storage. It's fast, responsive millisecond latencies. It has a durable, consistent, and highly available. It has high availability. And overall, with new applications these days, you need your applications to have most of these, if not all of these qualities. So one of the stories I like sharing is when Cosmos DB was originally thought of, approximately about 7 years ago by our founder, Dharma Shukla. He would think about how Microsoft applications had different requirements for release. And how the database wasn't doing enough to actually support their releases. And so with Microsoft applications going out to many different regions on day one, as well as scaling to the terabytes and petabytes on day one, he wanted to build an application or a database infrastructure for different Microsoft applications to have this easily available to them. And I'll showcase later exactly some of the Microsoft services that are using Azure Cosmos DB as their backbone, as well as other services that decided to bet on Azure Cosmos DB as well. So what are the things that really sets us apart? Well, it is that global distribution. This is fundamental to Azure Cosmos DB. For those of you who are familiar with NoSQL databases, one of the key things is how do we make sure that the data is always available to you? How do we make sure that your data throughout the year is 100% available to you? Well, the way to solve this, and the way to solve this with most distributed databases, is having local replicas. So what this exactly means is your local replica will have the same data as many other local replicas, so that if a machine actually goes down, another replica takes its place and actually become the primary or deliver all the reads. That logic applies at the local region. We've expanded it out and done something really special where we expanded it out to the global region, all global regions. And this turnkey global distribution can be set within our Azure portal with just a couple of clicks. So overall, we have an internal term we use to describe Azure Cosmos DB, which is we are a Ring 0 service. This is a term that's describing a lot of Azure services where they're the foundation for other Azure services. So as you can imagine, when we're rolling out to different Azure regions all around the world, we need to be there as one of the first services so that all the other Ring 1, Ring 2, Ring 3 services can onboard. And so Azure Cosmos DB is one of the foundations of Azure all up. Some of the other things that really make this great are its automatic multi-region replication. And so without really setting anything up from the user's end, you can actually go to the Azure portal and decide how many regions you want to replicate to. And this is done with just a couple of clicks. So we really simplified it for the user so that they can set up this type of geo-replication, this global distribution with ease. I'm not sure how many people have tried this in the past, but it used to be very, very difficult. It used to be you spin up your instance in, let's say, West US, you spin up another one East US, and now you're trying to make sure that's consistently through. You're making sure that the replication is always happening. But this is all taken care of for you by us. We have multi-homing APIs. So multi-homing APIs is essentially, if I'm writing to my primary region, but my primary region goes down for some natural disaster, we will automatically, through our SDK and drivers, shift you to the secondary region. So this is especially nice because the current state of the art across many databases is that if your primary region goes down, you need to redeploy your application pointing to your secondary region so that you have availability. But the one caveat with that is when you're redeploying, that means that you can have data loss up to an hour, 2 hours. And so we've really simplified things by embedding this logic into our SDKs as well as drivers so that we can automatically detect the next primary region and start restarting your application against there. We have automatic and manual failovers. This is nice just because I talked a little bit about the automatic failovers, but the manual part is that as you do some type of BCDR training, as you're testing out your application to see how long it takes for it to come back up, you can actually trigger your own manual failover so that you can test it out. And as I mentioned before, this is designed for high availability. We want to make sure that your application is up and running all the time. We don't think it's acceptable for applications to go down because the database goes down for a couple hours, for a couple days throughout the year. Especially for mission critical applications where this is the core line of business, we want to make sure that this is available all the time. And this is the philosophy that we approach databases with. So I have a quick demo to showcase, just to show you some of the global distribution. So this demo is actually showcasing the write latency as well as the read latencies of 5 different regions using our API for MongoDB. So this showcases that we're able to deliver that millisecond latency across many different regions. Usually I decide to take one of the databases out of a region just to showcase that your application will find the next closest region that has the database and will actually go there and do its reads, which is very nice. So overall, as you write data into your primary region, it's replicated automatically for your no real setup all the way to the other regions. And Azure in total has, I think, 40 regions now. And with 40 plus regions, you're looking at having your data anywhere you want it to be. So you can have it as close to your customers as you want to, as well as you can have it replicated in major continents just to make sure that you have that durability. Latency. So latency is a big value proposition for Azure Cosmos DB. We want to make sure that you have guaranteed latency at the 99th percentile. What does that really mean? When you break it down, it means that we want to make sure your database is fast all the time. We don't really accept being fast partially of the time. We don't really accept being fast where your data really isn't available to you, but we're fast just because the data has entered the database. So we want to make sure that for sure, we give a latency of 99th percentile. That's something that most people aren't really used to as of today. So the requests are served from the closest region. As you can imagine, serving from the closest region means that you get to minimize the network latency. Overall, if you're looking at a lot of applications these days, most of the time is actually spent on network latency. And so having that replication is super useful. So put it into perspective, one read request on Cosmos DB, the P99, is roughly, I believe, 5 milliseconds. If you try to send a request from East US to West US, I think that's roughly anywhere between 50 milliseconds to 100 milliseconds. And so you can imagine that most of the time is actually swallowed up where we're traveling over the wire. And this is just pure physics. Just sending light from one region to another or across continents takes a while. So we do have single-digit millisecond latency worldwide. We are a write-optimized latch-free database engine designed for SSDs. And so what does that mean? That means that as you're writing to your application, we are automatically indexing as well. This means that your writes are incredibly fast just because of the technology we use underneath. And we do have that synchronous automatic indexing, which can be sustained at high write volumes. So what does that mean? That means that if your data is coming in, we're automatically indexing on the fly. So you have that data available to you immediately. It doesn't mean that as your data is coming in, we'll index it later, and then your queries will eventually catch up. It means that on that spot, as you're writing, we'll automatically index it so that all your queries have the data available for it. So for those of you who are into databases, this slide will cover a little bit of a consistency levels. So the state of the art for most NoSQL databases are you have your strong consistency and your eventual. And this ties back into the local replicas I talked before. So one of the common things is if you have these local replicas with the same data, how do I make sure that if I do a write to my first machine and then I do a read to the second machine, that replication happens fast enough that I see the same data, right? But that guarantee, it's a trade-off. And this kind of delves into the CAP theorem, which is a balance of consistency, availability, and partition tolerance. And most people have strong and eventual. What does that mean? That means that if I write to my primary region or a primary replica and it's strong, then I have to make sure that that write persists throughout all the local replicas before I say, yes, your write went through. But that's the trade-off, right? The trade-off is now I have a little bit of extra latency when I do my write, because my write now needs to go and propagate through each replica before I get the acknowledgement that it's done. Eventual, on the other hand, is the complete opposite of the spectrum. It means that if I do my write into the primary replica, I don't really care if it's replicated all the way through. I just want the act that it went into the first machine. This means that it's possible that a second reader comes into and hits another machine and they say, well, the data is a little bit stale, but you can be okay with that. And different applications have different needs. As you can imagine with any type of social media site, having this bit of staleness in data is not too bad. When's the last time you've really complained because your Facebook wall didn't sync up automatically with everyone else's and it's identical across the board? However, strong consistency works fairly well for applications that require it, like financial information. Financial information, if you do a transaction, you have to make sure it's through so that everyone sees the same data. Is my mic a little spotty? Is that my fault? Is there something I could do with that? Oh, I see. Okay, so head straight, got it. So that's a little bit about consistency. And we've really innovated this space by adding 3 more consistency levels. And this basically allows you to have deeper integration and more tunable consistency levels to actually manage trade-offs. And so the first one we added was bounded staleness. Bounded staleness is essentially I want a max limit on how stale my data can get in terms of time or in terms of operations, so the number of writes or updates. And this is nice because let's say you want a boundary that's kind of like strong, but you could have a little bit of leeway, right? So if I'm writing 100 times, let's say I want this data to not be stale over 10 operations. Next, we have session. Session is our default consistency, and it means that as a user, you're guaranteed to see your own write. This is nice for anyone who's actually using the database and debugging or trying it out, where you're guaranteed to see your own write. And lastly, we have consistent prefix. A consistent prefix is a little bit different from everything else. It's the replication across local replicas. We guarantee that if you do write A, B, C, that A, B, C propagates in that same order across the local replicas. There are certain databases out there where you might go B, A, C, or C, B, A, and it might be out of order, which might work for your application or might not, but we do provide that guarantee so you can tune it yourself. This is a good one to talk about. So this is the elastically scalable storage and throughput. This is one of those canonical things within a database that really makes it special, when you can grow your data to the terabytes and petabytes scale without having to worry, as well as the opposite, which is throughput, which if I have 100,000 reads or writes, I'm spiking up in my traffic. Like, can your database really handle that? Can your database scale in terms of throughput as well? So we both have elastically scalable storage as well as throughput. We make sure that a single machine will never really be the bottleneck for your application. We have transparent server-side partition management. That essentially means that as you're interacting with your database, underneath the covers, it can be multiple machines, but we're synchronizing it, and we have a lot of the management so that it's almost like seamless that you're working with a single entity, which is our goal to you. Our goal is to show you a database where it seems like the storage is infinite as well as the throughput's infinite. Underneath the covers, we actually have multiple machines covering so that you can have that throughput you need, you could have that data storage you need, and we could separate across the data. One of the cool features we actually have is TTL. So TTL, for those of you who don't know, it's time to live. As your great data grows and grows and grows, some people do have to make a trade-off saying, we don't need the data after 5 years, after 3 years, after a couple months. And so you can automatically set a TTL on your database to say, expire out my data after this amount of time, which is very nice for those applications that are continuously growing and you want to prune your data over time. And all that pruning is handled by us. All you need to do is tell us when you want your data to expire. So this is one of the most popular things that came up within Build. And this is one of the things that really caught a lot of attention, which is our multi-model, multi-API. For those of you who are familiar with Azure Cosmos DB, For those of you who are familiar with Azure Cosmos DB, we actually are now a multi-model as well as a multi-API database. We are able to use the Cosmos DB infrastructure, combine it with familiar APIs so that you have a database that's truly flexible in nature where you can use it for many different applications. So what models do we support? Well, we support your graph. You have your document as well as your key value. For those of you who are familiar with NoSQL databases, you know that each one has different trade-offs as well as different types of operations that you can run on it. And so what we've done is we've adhered to a lot of popular APIs out there to make sure that you have the most familiar ones, the ones that you want when interacting with the database. Is it still spotty a little bit? OK. So you have something that you're familiar with. And this is truly powerful. This, in essence, with our MongoDB API, allows you to use the Mongo ecosystem with the Cosmos DB infrastructure. And for those of you who are familiar with other databases like Gremlin, the Gremlin query language, we expose the Gremlin query language on top of our graph engine so that you can use something that you're very familiar with. You can use a lot of the open source tooling out there with Cosmos DB infrastructure, which means you still get that benefit of everything I've talked about in the previous slides with things that you're very familiar with. I think the coolest thing is when I'm talking to a MongoDB user and I showcase Azure Cosmos DB, and they're able to take their application, change the connection string, and point it to Azure Cosmos DB, and everything runs. And the beautiful thing is now they're thinking about a lot of the potential where when their database grows or outgrows their machine, none of that has to be set up where they need to actually partition or shard it out across multiple machines. We can handle that for you. Availability. How do I make sure availability of the data set is very high? The availability, we guarantee it through multiple local replicas, but that's all handled by us. You don't have to set it up yourself. And we are allowing a lot of this logic to be placed on us so that we can free up time for everyone else so that they don't have to do a lot of this database management. So some of the APIs we support are, we have a SQL-like syntax, and that's under document DB. For those of you who've actually used a document DB API, it has a SQL-like syntax. You can also use a JavaScript, and we have multiple SDKs available for that. We support MongoDB. MongoDB has 15+ drivers, so you can use any one of those to interact with Azure Cosmos DB. We have table storage support, so this is Azure Table Storage, if anybody's used that. We actually have an SDK that has the same API layer as them, as well as Gremlin, like I talked before. So Gremlin is exposed for the graph interactions, and it's been very popular, and it's about to go GA soon. And the last thing I did want to highlight is you can expect more models as well as APIs to be added in the future. This is one of the visions for this database. As it continues to grow, as it continues to have more and more use cases come up, we'll be adding more models as well as more APIs. And so if you guys are interested in certain type of APIs, please go to our user voice and vote. That'll help us prioritize what we do next, as well as we want to make sure that we do make APIs that are widely accessible for people who want to use them. So one of the things that makes Cosmos DB so flexible in nature, for it to be adaptable in nature so it can handle different schemas, so that it can handle different APIs, is its schema agnostic automatic indexing. This is one of the fundamental parts of Azure Cosmos DB that allows it to have many different data types to come in, as well as different forms and shapes of data, and for the automatic indexing to be so fast so that we can have the data available to you as fast as possible. At the global scale, managing indexes is actually kind of a pain. And so we do allow automatic indexing where we can do a lot of the indexes for you. And the key thing is we do, by default, automatic indexing on all properties, but we do allow the configuration for people who want to fine-tune it. Overall, we see a majority of cases work when we do automatic indexing on all properties, but there are a lot of individuals who say, I want to fine-tune the indexes so that I can remove certain properties that don't need to be indexed, as well as I can add additional indexes onto it. And this is nice because there are a lot of power users who want to configure this further so that they can further optimize their database for them. We do support hash, range, as well as geospatial indexing. And this works across every model. So this is one of the core aspects of Azure Cosmos DB that's shared across each model. And this is a highly write-optimized database engine, which means if you have an application where there's many users who are all sending data into your database, we can scale for that, and we can keep up indexing with that, which is very nice. And a lot of our heaviest users actually push that to the limit, and we are able to support all of them. So next thing I wanted to showcase is the query playground. This highlights a little bit of our SQL syntax. I wanted to showcase it just because I can talk about databases for hours and hours, but really showing what the data looks like in one of the APIs, showing the SQL syntax, showing a couple queries, really gets a better picture than I'm able to do just by talking about it. So this is a website that's publicly out there, so you can access it at any time you want. And it showcases some of the query language that we have. And this is our SQL query language. The document that's stored within Azure Cosmos DB is of the JSON format. So you can see it has an ID here, a description, tags. It has a version, is from survey, food group servings. And so this data here can look vastly different from other documents. It doesn't have to follow the same schema, but you can interact with it with the same query language as such. And this is kind of the familiar syntax that everyone's familiar with who's come from a SQL background. So I can do a select star as well. Zoom in a little bit so it's a little bit clearer. So I can do a select star from C. This database doesn't actually have 100 documents. It has closer to 100,000, but we paginate so that we don't crash the website. We showcase some of the more advanced query options as we go along. So filtering is fairly easy with your where clause. We have order by top. And then it becomes much more interesting when you have in between your projections, your joins, your built-in functions, as well as UDFs. One of the things we like highlighting is our geospatial support, just because it's a very visual thing we can showcase. Right here, I'm finding a volcano near where I live in Seattle. For those of you who visited Seattle, this is actually Mount Rainier. And then this is all the volcanoes within the state of Washington, represented as a polygon. And as you can see, this is very different from the previous document I showed you. Oh, there's a question. I can't answer a question now, but usually we'll wait for the Q&A. I'll leave about 10, 15 minutes at the end. Perfect. So this is a sample document of a volcano. The data can look very different, but it can all be stored in the same collection or container, which is very nice, and that's where that schemaless nature comes in. SLAs. So this is something that we've kind of revolutionized within Azure, providing this SLAs better than a lot of Azure services at the time. We've actually expanded it, which is very unique. So for those of you who don't know, SLAs stand for service level agreements. This essentially, in just the most common words, is our promise to you. These are all of our promises, and these are financially backed promises, which means if we don't meet this criteria, then you can actually ask us for a refund. So the first one, the most important one, is our availability. We promise to you that we'll be available 99.99% of the time. We're getting much closer to 99.999% of the time, 5 nines, and this is financially backed. So this basically means that if you find your availability is lower than 99.99% of the time, then you can actually ask us for money. The next ones we've actually went into, and it's fairly unique to Azure Cosmos DB, is we provide SLAs on low latency, consistency, and throughput. So what does that mean? For low latency, we guarantee that your reads are less than 5 milliseconds at the 99th percentile for 1 kilobyte documents within, we guarantee that 99th percentile, it's less than 5 milliseconds for your reads. I think I butchered that a little bit, but yes, you get the point. Essentially, and we do that for 10 milliseconds for writes. This is within the same data center because we can't really guarantee just in terms of physics that if you're sending a request from Brazil into West US, it was guaranteed it'll take longer than 5 milliseconds just because of the wire time. But we do track inside a single data center how long it takes for us to deliver that read or write to you. And under 5 milliseconds, the 99th percentile is fairly unique. At the 50th, you're looking at closer to about 1 millisecond for the reads and 5 milliseconds for the writes. And by the way, all of these things we actually showcase in metrics in the portal so that you can keep us honest. Because there are the questions that come up afterwards is, okay, you make all these promises, but you make it very difficult for us to put you to it because we have no idea if you're hitting it or not. So we do expose the metrics in the portal so you can keep us honest. Consistency. Since consistency is such a huge value proposition for Azure Cosmos DB, we showcase metrics to show how consistent your data is and whether it adheres to the consistency levels that you set for your account. And lastly, throughput. We guarantee to provide you all the throughput that you've set up for your database. So if you set up your database so it can handle 100,000 writes per second, 100,000 reads per second, we guarantee we'll give you all of that throughput all the time. 100%, there's no leeway on that for us. Security and compliance. So this is one of the unique things that really sets us apart from a lot of the other open source competitors out there. So security and compliance all up is something special that Azure does to make sure that for enterprise, for a lot of enterprises as well as businesses, that they can use this database and feel secure. So some of the features we provide are we're always encrypted at rest as well as in motion. We have fine-grained row-level authentication through users and permissions. And we have a comprehensive list of compliance certifications we've already achieved, which are ISO 27001, ISO 27018, the EUMC, which are the European Union model clauses, HIPAA, PCI for credit card information, SOC 1, and SOC Type 2. And this is an ever-growing list. We're constantly working on growing this list further and further. And the only reason why there are a couple things missing as of right now is because the audits are happening right now. And as you can imagine, there are probably a number of you who've gone through a lot of the certification. These audits take quite some time. And so you can imagine that we're always being audited every day just to make sure that we keep up a lot of the certifications. Total cost of ownership. So for total cost of ownership, one of the things out there is Amazon's DynamoDB released a white paper on how cheap it was to actually run your DynamoDB instance. And we've actually replicated their experiment they ran within their white paper on Azure Cosmos DB. We found that we're about 3x cheaper. So for those of you who are interested, we've published this white paper online. So please go and please visit it and read through it. So overall, some of the things and reasons why we are cheaper than a lot of competitors is because of the multi-tenancy, right? So on a single machine, physical machine, we can actually lay out multiple different tenants on it. So if you decide to use only, let's say 100 reads or writes, you can scale down so that you're only paying a couple of dollars per month, which is nice. Which also means that we can pack in more tenants onto a machine so that we can make almost economies of scale, where as we get more users, we can scale it down and we could have more people packed into many tenants. And obviously, some of the other things that influence the total cost of ownership is a lot of the maintenance is handled by us, right? So upgrading your database, which can be very painful at times, is handled by us. All the maintenance of deployments, live site incidents come to us. We have on-call teams who are 24/7 making sure that we're here for any of your requests and any of your issues. So who uses Azure Cosmos DB? As of right now, Skype actually uses Azure Cosmos DB. Skype has around 44 terabytes of message data. They have about 1 terabyte of group data and 6 terabytes of users' data on Azure Cosmos DB. And what was some of their reasonings for why they chose this? Well, they needed a rich, expressive query language. They had high latency requirements, so they wanted to be very, very fast. They were very strict on that, as well as they wanted to be highly available. So as a database with local replicas, as well as able to scale out regionally to any different region you want, this high availability was satisfied just by us, and this has made sense for them to use Azure Cosmos DB. Yeah, just waiting for the pictures. Next, Toyota. So Toyota uses us for their IoT scenario. So why does Toyota use Azure Cosmos DB for their IoT scenario? Well, some of the things that you have to think about with IoT is you can have up to 100,000, 200,000 sensors all emitting data points every second. So you need a database that can really scale in throughput. As well as they have, same as Skype, latency requirements. Some of the use cases that Toyota proposed was that they wanted to have functionality that were similar to almost like OnStar, where if there's a crash, they want to alert the ambulances, they want to alert the right people immediately, right? So you need an incredibly fast database for that. Initially, they were using our MongoDB API, which made it very easy for them to onboard to Azure Cosmos DB, because they were already having a lot of MongoDB instances to begin with. So they give about 8 terabytes of vehicle telemetry, and over 250,000 Lexus cars right now are emitting data points to Azure Cosmos DB. As you can imagine, they're rolling this out to other vehicles. So you can imagine this data growing very, very fast. Jet.com. So for those of you who are familiar with Jet.com, they're a large retail site. The reason why they really Azure Cosmos DB was its scale. So one of the key things you have to think about with e-commerce sites is that their scale fluctuates with the seasons, right? So holiday seasons, you'll find a huge increase in usage. And so one of the key things is they were prepping for Black Friday, as well as Cyber Monday now. And they're, the predictable spike in usage, but it's a fairly big spike in usage. And so with Azure Cosmos DB, let me just put up the architecture. With Azure Cosmos DB, you're able to scale up your throughput so that you can handle all of the requests coming in. And the other side of the scalability is you can scale down as well. So most databases these days talk about how you're able to scale up, up, up. Very rarely do you talk about scaling back down. But this is the nature of applications. Applications these days need to scale up for certain spikes and need to scale down afterwards. And so we make sure that you can scale up and down, and so you can adjust for your usage patterns or your application's patterns. So how many people know Walking Dead? Awesome. Perfect. So Walking Dead, their mobile game was one of our earliest customers. They came in with a requirement where they were about to release their official game with the season opening of Walking Dead. They needed to scale, needed to make sure that they can handle all of their users. But as you can imagine with releasing any type of mobile application, it's very hard to accurately predict how many users you'll get, especially latching onto such a popular franchise or show like The Walking Dead. And so they needed something that can really scale. They needed something that was light management just because they were a small team at the time. And so they decided to go with Azure Cosmos DB. Some of the things you can imagine is they had a regional rollout where they wanted to make sure that that game was available in many different continents and many different languages. And this is all kind of possible with Azure Cosmos DB. Perfect. So I'll just wait for the pictures to finish. Sorry about not putting the architecture earlier. Awesome. So I'll talk a little bit about the system internals. Just because for the most part, with most of these overview talks, talking about how great the product is overall doesn't build as much trust as if I could tell you how it works internally, because overall, it's just technology, right? It still is technology where, it's not magic. In the end, it's a lot of hard work, a huge team that was able to build this out. And so I want to talk a little bit about the internals on how this thing works. So this is our resource model. We have the account at the top level, databases. You have your collections closer to containers, and you have your items, which go underneath it. And in this resource model, a lot of the interaction is happening on the container level. At the container level, you're able to dictate and decide just how you really want to interact with your database. What does that really mean? It means you can set throughput on the container level to make sure that your application can set aside more resources for the collections that are more heavily used or will have more data, and you can reduce the throughput and reduce the provisioned resources for collections that might not have that much usage. So this is very flexible in nature so that you can dynamically adjust how much resources you want on each container/collection to make your application is saving as much cost. Is everybody okay? I feel like it's still going in and out, but everyone's fine? Okay. This resource model is, you can have stateless interactions with each one using HTTP or TCP. And when working with Azure Cosmos DB, it's best to familiarize yourself with the resource model just because you want to actually know where the interactions play, right? So for users and permissions, that's on the database level. So when you want to set that up, you can set it at the database level. For collections, you can set the throughput. And this is all interactable through different drivers, different APIs. So you can interact it with how you please. So horizontal partitioning. This is one of the critical aspects of Azure Cosmos DB. So I'll take some time to delve into this. As you can imagine, when you're having a database that needs to scale out in terms of throughput as well as storage, you need to choose a proper partition key. So what is a partition key and why is it so important? So when you're partitioning your data, it essentially means you're telling us how you want us to separate your data across machines. So overall, this is incredibly important because if we don't have a good partition key that doesn't correctly identify where your data is, it's difficult for us to predict where your data is. For example, I think the classical canonical example I always start out with is, let's say, a phone book, right? So you have your phone book. Your phone book is usually alphabetical. But let's say when you want to interact with the phone book, you're looking for zip codes. Most of the time, let's say you're looking for zip codes, where it's very, very difficult within a phone book to go through and find, let's say, zip codes or street names for each individual, just because it wasn't ordered that way. Same thing with the partition collections, right? So if you partition it based off a first name, it's difficult for us to predict where individuals are based on locations. Granted, it doesn't actually take us long to find it. So overall, what we can do is go to each machine and say, do you have everyone from zip code 07675? And we can roll through all of it and get you your data. And it won't be that fast. It won't be that slow because we can find it that way. But the one issue is we have to look through every machine, right? So as you can imagine, when you're trying to scale, when you're trying to optimize so that you can have terabytes, petabytes worth of data, as well as 100,000 writes, 200,000 writes, choosing this is incredibly important so that we can say, oh, you're looking for Andrew. Well, all the A's are within this machine, so we can find it just by looking through this one machine, right? So overall, we like to put a heavy emphasis on partitioning so that this one-time cost will be amortized across for the rest of your application's lifetime. This one time, you have to really decide on how I'm going to scale, how my usage of my application will go through, and how I'll be able to better prepare for the next 2, 3, 4, 5 years. And this one-time cost is something that only needs to pay at the beginning. Afterwards, it happens seamlessly. Because from that end, we know how your data is set up, and we know how the interaction is. And so we can optimize it, so how the data is separated across machines, how your queries interact. We can optimize it so everything's very efficient, right? But as you can imagine, it's very hard for us to predict the partition key or how we should partition because we don't know inherently every user's application patterns, right? It's very difficult for us to predict how one person will use their application versus another, even when they're in the same vertical. We've seen so many different application types, even within finance, within healthcare. So it's very difficult for us to predict that. And so this is one of the criteria we ask amongst our customers to choose a good partitioning scheme so that they can be better prepared for the future and so that we can do as much as possible from the database side to make it as easy for you as possible. So this is covering a little bit about what I've talked before. I believe the example right here is airports and how the partitioning is done across all the resource partitions, which are the machines. And some of the best practices. So you do want to make sure that things that are queried or interacted together are within the same machine. So let's say most of the time I get individuals with the name Andrew all with the same query all the time. Well, having that all on the same machine is very useful for us because we can just send a single query, right? But if it turns out that you did your partition key as last name, but you keep searching for everyone whose name is Andrew, then we do need to go through every machine to find every Andrew that is available there. The other thing is optimizing your workload for partition collections doesn't mean that every single query needs to be optimized, right? It just means that the majority have to be optimized, right? So that query that you run 90% of the time, 80% of the time, we should optimize for that. But the queries, the 10% of the queries that go and have to go through every machine, that's an okay cost. You can pay that cost. As long as your query as well as operations that run most frequently are optimized, your database is set up to scale. One of the common partition keys we see all the time, which always leads to problems, is timestamp. Logically, it makes a lot of sense to use timestamp because it seems like a natural divide of data. But when you start thinking about it a little bit more carefully, it becomes, you start seeing some of the flaws in it, right? And so I've worked with a couple of airlines on their applications and partitioning. They wanted to go with timestamp, but as you can imagine, this is not a good one just because how many people fly back home for Thanksgiving, for Christmas, right? For all of those, all the writes are coming in, and they're going into the same exact machine, right? And so I'm booking tons of flights. All people around the world are booking flights for Christmas. And all of those are going into a single partition to do the writes. And so this inherently is not scalable because let's say I have a database that has 100, 1,000 partitions, yet at Christmas time, everyone is going to that one partition for their data, or writing their data, reading their data, everything. And so this one's going to run hot. So overall, timestamp is a fairly bad choice for partitioning just because it doesn't scale that way. So what are other ways you can do it? Well, for the Toyota case, we've actually partitioned by VIN, the vehicle identification number. It's fairly distributed, so it's across all the machines, as well as is optimized for the queries, because a lot of the queries actually use the VIN for vehicle lookups. So overall, it's a little bit of exercise. We do have a white paper out there that describes what are the best practices, how to go against this, what kind of data you need in terms of your queries, your read and write operations. And it does handhold you a little bit through this process so that you can best decide how to partition your data so you're better prepared for the future. As I mentioned before, Cosmos DB handles the requests to partitions. So you don't need to specify which machine you want to go to. We know how the partitions are lined up, so we can do that for you. Overall, you have to make sure that, as I mentioned before, that there's no excessive fan-outs. Fan-outs are essentially going to every single machine and asking for the data just because we don't know where the data is. So you want to make sure that you hit a single machine. That's kind of an overall takeaway. Another thing to note is the partition key is the boundary for cross-item transactions. So this means that if you do want to do, let's say, player A gives player B, X number of tokens, you want to make sure that they're within the same partition so that they can be transactionally bound. As you can imagine, it's not truly scalable when you lock down multiple machines just for 2 players to interact with each other. And as you can imagine, more complex transactions where it could be across many players, if we have to lock down your entire database, this is not inherently scalable. And an ideal partition key enables you to use efficient queries and has sufficient cardinality to ensure your solution is scalable. So that's a good point, though, the second part, which is you want your data to have enough cardinality, so distributed enough so it separates quite a lot, right? So if it turns out that you're selling, you have your application released in Seattle, you do not want to make your partition key Seattle. That will put all your data into a single machine. So maybe use zip codes, or maybe use first name, last name. So you want to make sure that it has enough cardinality and it's distributed enough so it can be on many different machines. Yep, so for global distribution, I'll talk a little bit about how it's separated out, how you have your data in many different locations. So for global distribution, all the writes go to the primary region, and the primary region is able to replicate the data to all the secondary regions. This is nice because when your application is running in many different regions, it can go to its local database with all the same data as every other database or replicated part of the database, and you can access your data with low latency. Overall, there's 2 canonical use cases for using global distribution as well as kind of the geo-replication feature, which is 1, high availability, right? I want to make sure that if my primary region goes down, something else is there so that my application has no downtime, period, right? So we do see a number of people who have just 2 regions, which is their primary one and a secondary one. Why? If something just, a natural disaster happens, right? Let's say electricity completely out or something. You at least have a second region that could take its place, and your application has no downtime. Second, low latency. So low latency is also key. A lot of different users have replication across many continents just because the trans-ocean networks are fairly slow, and so they tend to have a setup across all the continents so that they have low latency for their users, right? So one of the typical use cases is websites, right? There's a lot of statistics out there that say that as your latency grows for your website, your conversions actually drop, right? And so a lot of, even internally in Microsoft, a number of websites out there say, we can't have our database be slower than 50 milliseconds, 10 milliseconds, 5 milliseconds. And they come to us with these requirements. So request units. So this is a topic that's always interesting to talk about because it has split feedback where some people are like, yes, that makes sense. And some people are like, that is very confusing. But overall, if you're familiar with SQL databases, which has DTUs, Cosmos DB runs on RUs, right? So The number one question that comes up is why RUs? It's very confusing, right? Why? It makes no sense to me. It seems like an arbitrary unit. But overall, it was introduced to simplify the logic for our users. So RUs are basically your percentage of CPU, percentage of IOPS, and percentage of memory normalized to a single currency. When we were debating on whether to showcase all of these individual metrics as charges, it becomes very difficult then for users to figure out, well, how do I optimize my database? And it becomes very heavy. The complexity grows, and so overall, we've decided to have this normalized unit as RUs, which is nice because as you decide that you're running out of resources, it's just a single slide bar where you can say, I want more RUs. These are provisioned resources, so we guarantee that as your application sets aside 1,000 RUs or 2,000 RUs, we set that aside for you so that you can use it. So it's always available for you. And kind of putting into a little bit more perspective, about 1 RU is equal to one read of a 1 KB document. So if you set aside 400 RUs for your application, you're looking at about 400 reads of 1 KB documents per second. Writes are about 3 to 4 times more expensive. Why is that? Why is that the case? Why are writes more expensive than reads? Well, alluding back to what I talked before about having your local replicas, with a read, we can go to any machine and say, what is the document XYZ? For writes, we have to go to your primary, and we actually have to replicate and rewrite that data across all the local machines. So that's where the extra cost comes in, especially for writes as opposed to reads. So these are provisioned in terms of RUs per second. The rate limiting is based on the number of throughput provisioned. So overall, if you provision, let's say, 400 RUs per second, if you decide to exceed that, we do rate limit, say that you've hit the limit. Luckily, in most application cases, with a little bit of throttling and retrying, you're OK. And we have that logic already embedded in. So let's say I'm writing 450 RUs per second. We will automatically retry the second after when your RUs replenish so that you can get those writes. So just to show you, we have a website out there that'll help you understand RUs a little bit better, as well as plan for the future. So I have a sample JSON document on this website here, and I'll zoom in so you guys can see just a little bit better. I have a sample document here. I've uploaded it into the website. I've said how many documents I want, which is just 1, and the number of reads per second. As you can see, if you calculate it out, it comes about to 1 RUs per second over here. Ooh, over here. Perfect. So if I were to change this to 2. So 1 second. So yeah, so I believe it's saying that 1 RUs per second for the operation, and the amount of data storage consumed is 1.87 kilobytes, which are both the data storage as well as index storage. And index storage is fairly small compared to data storage. So in summary, some of the points to take away with this. Azure Cosmos DB, the globally distributed, massively scalable, multi-model database as a service. It has an API for SQL. It has the JavaScript, Gremlin, table APIs, as well as the MongoDB API. The models it supports are key value, column family is coming soon, document, and graph. And the value props that really make it special are its turnkey global distribution, elastic scale out of storage and throughput, guaranteed low latency at the 99th percentile, 5 well-defined consistency models, as well as our comprehensive SLAs. So we do have a website out there called Try Azure Cosmos DB for free. Well, you can try it for free, and the actual name is azure.microsoft.com, try Cosmos DB. We actually provide you with a Cosmos DB instance for a day, and you could extend it out to 48 hours. This is a great way to try the different APIs, try the database out, figure out if it fits your needs or not. And I believe I do have the website open, so I can show that as well. So this is the website over here. And you could try it for the amount of time you want, as well as I believe there are a couple other options you want if you want some type of free tier. Perfect. So I'm just at the Q&A section, so we can start that. 1 second. Yeah, so you can get free credit to actually try out with Azure Cosmos DB. If you could say that at the mic for everyone to hear, that would be perfect.
Yeah, so we just released a free trial. See on.
Is the mic? Excuse me? Is the mic on? That one.
Yeah. Nope. Not yet. Testing. There we go. Yeah. So azure.com/free, $200 free trial. It's probably associated with some MSA account you create, but go for it.
Perfect. Yeah. So both of these are great resources to try out Azure Cosmos DB. And here are the related sessions that we're talking about. We'll go a little bit deeper into a lot of these concepts. We'll talk about the MongoDB. We'll talk about how to go from internet to enterprise. I have another talk on data science with Azure Cosmos DB. Design patterns and case studies for globally distributed applications, which will talk about some of the customers and how they were able to go with the globally distributed applications. And Internet of Things, for those of you who are interested about IoT, definitely recommend that one. And here's the slide for evaluation that's in every talk. And I'll take questions for the last 15 minutes. Awesome. Cool, go ahead.
Yeah, it looks like there are some aggregate functions, but that's not in the playground to test out.
Yes.
With. It looks like count's the only one, count values.
So some, min, max, average, count are all there. And actually, they are available in the query playground. We just haven't made lessons for them.
Oh.
And so if you decide to actually put a sum or count, it'll all work there.
Okay, what about group by?
So group by, group by is a tricky one, just because doing group by right so that it can scale and so that your applications can scale out and hit this kind of terabyte, petabyte level is very difficult. So this is something that we're still working on, but not there as of yet.
Okay, thanks.
Cool. Hi.
Hi. So you have this database that's globally distributed. You can have many, many different regions.
Yes.
For availability.
Yep.
What is the limiting factor here that gives you only 4 nines?
So that 4 nines is based on one region. So that number is based on a single region. As you could imagine, if you're scaling out more, you'll have higher availability.
So to compute this, then you do your traditional parallel computations for availability?
For computing it, we would have to run more tests, right? So the way it's computed, it's not more mathematical. It's more of we have metrics to track against each region to make sure how many requests are successfully delivered and how many are failed because of service and availability.
Okay, bottom line, if I need 5 nines, so I work with you guys to figure out how to design
Yes.
this? Okay.
Yes, that's possible. Feel free to come afterwards and I'll give you my business card and we can sync up afterwards and get that done. Awesome. Other questions? Yeah.
Yeah, hi. Learned about time series insights yesterday. So I'm wondering what's the right architectural pattern for IoT data, which is of course time series. It seems like time series insights is not meant to be the long-term data store. It sort of windows through. I think today it's 30 days, soon it'll be a year. So is Cosmos DB a reasonable first landing zone for the data and then an ETL into time series insights or vice versa or something else?
So overall, I would say it's Cosmos DB is a good fit for that kind of initial data store where you need the fast ingestion rate, as well as you need some type of ad hoc querying on top. A lot of IoT scenarios have triggers or different things alerted based off of the incoming data, which makes it very useful, where we just recently announced how you can use Cosmos DB for triggers on functions, so that if, in the Toyota use case, if you get an emergency alert that a vehicle has crashed, that can be triggered automatically from Cosmos DB using functions and send an alert and contact the appropriate individuals.
That would be instead of streaming analytic job?
So you can do it at both layers, actually. Yeah.
Yep.
But with Cosmos DB, now you have a persistent data store.
Yeah,
So that's logged permanently, and you still get that millisecond latency overall. And then doing it into some type of time series database or time series insights, or a colder persistent store, maybe like blob storage as well, is a fairly good architecture. Just because if you do want to get the insights over time, you can have it in the colder storage, and then you can run, let's say, a Spark instance on top of it to get your insights. So yeah, so it's generally there isn't a proper pattern over there, but this is kind of the architecture of what we've seen over time.
Okay, great, thank you.
Thank you. Hi.
Since it's multi-model, I'm curious on how some of the models look like they work very well with the architecture of Document DB, and then others kind of gloss over a handful of details. So if we have a document store, lots of similar documents, and we create a partition key, that makes a lot of sense. But how does this translate over to Graph API? I've seen a lot of things where all of a sudden they just say, well, just don't worry about that. So with Graph API, if we have a lot of documents, but then we have our customers, our orders, and these other entities that we're all linking together, how do you build a partition key for that when you don't even have the same key value to partition across between a customer and order, a document, a part, a mention?
Yep. So overall, the partitioning works in the same way where you can dictate it, but if you don't have a property that actually goes across all these entities, you can always default to the ID. So the ID is uniformly distributed, it's guaranteed to be unique, and you can have it across multiple partitions. The nice thing is the Graph API works with this, where it can ingest the data from all over, so do a fan out. But overall, we do recommend having a partition key that's based off of some value that's inside the graph vertices. It sounds like in your case with the orders and the sales, it doesn't seem like there's a logical break in it.
There isn't, and so and graph traversal feels like every query is going to cause a ton of fan out. That's why I was curious how GraphDB and the lack of talking about how keys work with GraphDB causes a lot of the same problems you're trying to quickly avoid when you have a document store.
Yep. So overall, I wish there's a better story, but ID is the one. And then potentially having another property on top where you have a compound of your order ID or some type of indicator that's evenly distributed. If I took a look at your documents, I might be able to find some commonalities between the two. Or if it's not super common, the one that you can also think about is the properties don't need to be everywhere, right? So if you have, let's say, a few number of sales as opposed to orders, then you can use the order ID to separate, and the ones that are null values will just be entered into a null partition. If it's pretty evenly distributed, the same amount of documents on both, what we can do is also have a pseudo property that overlaps essentially two property keys in each one, right? Because overlapping doesn't really matter. The IDs will be unique no matter what. And so that's another pattern we can do. There's a couple of workarounds there. And if we can sync afterwards, I can help out with that too.
My question has a little bit to do about that as well.
Sure.
So let's take your example where you have entries in a phone book and you'd like to be able to find them by zip code or by their name. How would you choose to partition it, and then what would it look like if you searched by the other?
So, and which API are you talking about? Kind of the canonical document or SQL one?
Yes.
Okay, and what were the two types again?
I'll say the last name and the zip code.
I see, last name and zip code. So the way is you can also append both together, and then you can have some client-side logic to say, well, if this is going to be, last name plus this together, you can root out your query so that you can isolate down to which one you want to get to. So in essence, it's almost like you have one partition key, but you almost interacted with it as if it's two. The other option is probably a little bit better of an option. You can also have it in multiple collections if it's possible. So it sounds like it's two different separate documents, which means that you can actually have one in one collection for all your, is it orders, and the other one in another collection. And then you could have essentially 2 partition keys there. And then for extracting the data, you just need to submit 2 queries to the collection to extract both data to the client side that are related with each other. Does that make sense?
In the case where you're compositing the keys, would you handle that on the database side, or would the document have to contain that property?
The document would have to contain that property. So composite keys are on the roadmap, and they're coming up. But as of right now, it would be happen client-side logic. Cool, thank you. Hi.
So I have a question that's related to high availability.
Sure.
So typical application 3-tier based. Are you familiar with Oracle's real application clusters?
Not too familiar.
Basically, you have a single database
Okay.
with 2 or more instances that can
Okay.
both read and write at the same time. So 2 machines, I
So
could put them
multi-cluster.
exactly.
Okay.
Can you compare and contrast this to that? Because it seems to me like I could use this to achieve the same thing that Oracle is providing with RAC, but use Cosmos DB to do it up in Azure.
So I would say the difference is right now we're a single master. So I don't know how they would do their multi-master, but with multi-master, there's additional complexities where if you're trying to sort it by timestamp, having machines that have no clock skew, where you have a atomic clock across all your machines is very, very difficult to achieve. And I don't think they've achieved that, which means it's either that or they have some resolution patterns where it's, let's say, you as user A have priority over user B, and so that always overwrites that. And so I would be interested in figuring out in terms of their multi-master how they resolve that. I'm guessing it might just be eventual, which is if you write and you write, one of them will be written on top and one of them will be overwritten, but we don't guarantee which one, which is why we went with single master to begin with. Because the complexity with multi-master is very, very difficult overall. The other thing to note is it seems like Oracle's multi-master replication is a little bit on the uppermost layer where you have 2 database instances and then you basically have a pipeline on top which is doing the replication. Underneath the covers, we have the consistency level guarantees, which is basically because we're leveraging our internal replication in order to get everything done, which means that we can put all the guarantees that we have, like strong consistency, eventual, bounded staleness, and those I don't think Oracle is able to provide just because of their implementation details. So I wouldn't say it's an apples to apples where you can do one there and then the same thing in Azure, but it is comparable from what it seems like.
Okay,
Yeah.
thank you.
Cool, thank you. Oh, yep.
With because with the lack of aggregation that is inside Cosmos DB, it seems like every presentation that involves lots of analytics, then it has the Spark connector.
Yep.
So one, which follow-up session, which deep dive is going to be best to look at integrating analytics with Cosmos, and 2 is Spark streaming and reading the data out of Cosmos, or are you guys using the event system to store a copy somewhere else and analyze? I'm just curious what that Spark looked like at a high level.
So overall, Spark, its implementation is essentially it pulls out the data and keeps it in memory so it can run all the Spark jobs on top of it. So overall, it's not like we import that data into another data store and then Spark connects to it. It's more Spark ingests that data, keeps it in memory, and runs all the application details.
Ingests it one time, once every 15 minutes, it seems like it's a really high RU activity.
So it can be a high RU, but reads inherently are much cheaper on Cosmos DB than writes. And so when you're pulling out data from Cosmos DB, it's fairly cheap with 1 RU per 1 KB document. And overall, you can also do query predicate pushdown, which is I can tell it which documents I want before it ingests the data, so I can really fine-tune the documents I need for the Spark job rather than pulling out all the data. And so the query language is kind of your friend at that point where you can push it down. And the best session to attend is actually my other session, which is the real-time data science with Azure Cosmos DB. So I'll dive a little bit about how Spark works with Cosmos DB, and I'll run through some Spark jobs through Jupyter Notebooks on Cosmos DB, and show how to highlight a lot of the features, how to have the best application and architecture designs that leverage both qualities. Cool?
My question is, when do you think is necessary put Azure Search over Cosmos DB?
So Azure Search is really good for like fuzzy text search, where if I misspell my name, Andrew, that it can find that, as well as it has localization, so it has support for many different languages as well. And so overall, our recommendation is if you're looking for really rich search, like fuzzy text search, full text search, if you have large amount of text and you want to parse through each one and figure out, almost tokenize it to figure out what's inside that large text, definitely go with search on top of Cosmos DB. If it's very simple, like whose first name is Andrew, right? That's a simple query that you can just push to Cosmos DB and that doesn't require search. So overall, if you're looking for a really deep search integration that requires some of the nuances with any type of search engine as of today, then definitely go with Azure Search on top. Yeah, cool, thank you.
Oh, I got tons of questions.
Yeah.
For people that are switching from a SQL model where everything on Earth is relational joins, have you seen some really common anti-patterns that SQL developers aren't even aware that they're pulling into this NoSQL Cosmos world? Like what's the most common gotcha? Like everybody that does this first tries to do this and it's a bad idea.
Yeah, so the most common gotcha is always they try to do a one-to-one mapping. Like every row in the table is equivalent to a document. Naturally, that doesn't work as well because you're looking at a database that's looking to scale and joins. Obviously, joins and Cosmos DB is not really supported across many different collections, or essentially that would be the tables in SQL. And so overall, that's the biggest gotcha. And so overall, my advice is always try to denormalize, try to put more of that data together. Rather than having everything split out into a different table, try to group it up together as much as possible so that data is there available to you all together, and then you can just retrieve it on one go.
So is one 32K document a little bit more efficient than 32 1K documents?
The efficiency depends on what your operations are. And so if your operations are, I want to do a join on that, and that, and that, and that, and that, then essentially what we have to do is we have to go into the database, figure out each of the documents you want and join it all together, which is inherently is very, very costly of an operation, even in SQL. And so overall, what we recommend is 32 documents that are commonly used together and reads that are commonly written together, just keep it together. Why are you separating out, you know? So that's kind of our goal. Yeah, I don't think there's another question if you have another one. There might be a question behind you. Yeah.
Background would be financial organizations, so we do care about the consistency side of things. We're heavily trying to leverage like functions for kind of the serverless scale. Is it effectively that we would have to, on the range of durability, whatever, we would have to go with the far left in order to make functions work because there's no concept of a session or whatever, you'd constantly be connecting and disconnecting and things like that?
Oh, so strong consistency?
Yeah. Pretty much, if you want strong consistency as a thing with, serverless, with, tons of parallel computing or whatever, you can't guarantee, is it the only option to go far left on that, or have you seen other patterns?
For the most part, you have to go far left on that, especially for financial applications. That consistency is a core requirement. We see everyone pushing that strong consistency rather than, because the amount of management you need to do with the other ones, like such as bounded staleness or even session, it becomes a very costly thing in terms of just the amount of code you need to write to get it all into the right state. And with that, you can imagine that the couple of nuances where you might have an edge case that causes inconsistency could be very disastrous for any type of financial application. And so overall, we recommend going to strong for that.
And so I saw Skype, Toyota, Jet, Walking Dead. Do you happen to have any financial markets use cases yet?
We have a lot, but as you can imagine, it's hard to get the NDA, the PR release for financial applications. So we do have quite a bit. And fintech is actually one of the, I would say, one of the industries that are really growing fast in Azure.
Okay, cool. I'll give it a chance.
How about tracking data changes and versioning of documents? I've seen some graph theory where they point to multiple versions, or this is your current role today, but last month you worked in that department, and the year before you were in this department. I've also seen in one or two sessions they mentioned keeping those changes outside of Cosmos in some other Azure like changelog product. And I don't really know very much about either of these approaches or what they are, or what to even ask about.
Yep, so there's a couple things. We do have change feed, which can be used. It's a semi-versioning, but the only thing is it's almost like the latest, some of the changes might get lost just because we do couple it together. Instead of having a full log of every operation, we do start compressing it, which means if I do change A, B, C on the same document, we'll start compressing it down to just change C, just to save storage costs. But eventually, we're actually moving to something called a log store, which will keep all the changes, which means you can actually do that, canonical use case that you talked about right now. Besides that, I would say the best option would be to do the versioning inside the documents. So when you save the documents, you can do a V1, V2, V3, and then usually the last one you have some state like latest, right? So that your queries are super efficient where you can filter down on the latest property rather than saying, find every version and give me the latest ones of each one, which is a very complex query. So I do recommend going with versioning inside just with documents, adding a version property, and then start going on it, and then pruning it out, setting a TTL after a certain amount of time because the storage costs can be heavy. Just if you're saving the version of every document, it can have a lot of duplicate data. So I would definitely recommend do TTL so that you keep
What
it
about
small.
for short term? Like if we run through Azure Functions, we're ingesting data, and we're going to be merging different sources, sending it out to ML. We're going to have a big stream of updates, and then when something goes wrong, we want to see over the past like 3 or 4 days what would happen with this document, and then it becomes kind of finalized. Is there a good external solution?
So it seemed like a time series database would be very useful as well. So if you have a time series database and you want to just look for, ID of the document plus a time range for all the changes that happened, it can be useful to use any type of time series one. And I do know that there's a time series one in Azure, which can work very well with this. So rather than doing your writes just to Cosmos DB, you can do the final write there, and then you can have the change time series database.
Okay. Were you talking about using Cousteau?
Similar to Cousteau, there's another one, I can't remember the name, that's in public preview as of today.
Oh, as of today.
No, not as of today. It's been in public preview for a while, but I can't remember what the name is. Real-time analytics, or there is a service out there in Azure. There's a lot of services in Azure. No. It's one specifically for time series data, but the technology is actually very similar to Cousteau.
Yeah. Does Cosmos DB, did all of those changes surface at all into OMS?
So with the diagnostic logs, you're looking at aggregated, and you won't have the full document because we cleanse out the document because that goes against PII, where if we save your document in our log. So what we do is we cleanse out all of that, even IP address, we cleanse out the last 3 digits of the IP address, and then we expose that as logs, and we also aggregate it.
Because if it didn't, you could use...
Yeah, you can use OMS to down.
Yeah. Repository now and then...
replay, yeah.
Yeah, turn it into a time series.
Yeah. Cool. I think we have to wrap up soon, so this might be the last question.
In that case, backups. So for example, obviously it's HA, whatever, but sometimes a person makes a mistake, and so it actually is consistent, but in a bad way. What do you think the best strategy is, or is that documented somewhere?
So internally, we have backups. So we do get a lot of support tickets of people who say, I made a mistake, can you please kind of back this up?
The truth as of yesterday, as of last week.
Yeah, but the thing is, I think you're looking for a little bit of a deeper one where you can customize your own backups or even point-in-time restores, which are on the way.
Okay, so that's an on-the-way feature?
Yeah, exactly.
Okay.
And we do see a couple of people do it with, let's say, the data migration tool to export all the documents as like a JSON file, but it gets a bit hairy. Cool. So I think we're out of time, but I'll probably be at the expo hall at the Cosmos DB booth. Please feel free to come with all your other questions. Happy to answer all the questions there. And please attend some of the other sessions as well. Thank you so much for your time.